Introduction to Agricultural IoT. So here this is the architecture of the agricultural IoT. Currently, IoT-enabled technologies are widely used for increasing the crop productivity and revenue, that is generating significant revenue and efficient farming. So the development of the IoT paradigm helps in precision farming, and the agricultural IoT systems perform the crop health monitoring, water management, crop security, farming vehicle tracking, and automatic seeding, and also the automatic pesticide spraying over the agricultural fields. So in an IoT-based agricultural system, there will be different sensors, like they have to be deployed over the agricultural fields, and the sensed data from the sensors need to be transmitted to a centralized system, and or the entity such as the server, cloud, or the fog services here, and fog devices, sorry. And further, these data have to be processed, analyzed, to provide the various agricultural services. Finally, a user should be able to access these services from the handheld devices such as computers or the mobile phones and all. Okay. So here it shows the basic architecture of an agricultural Internet of Things system, where different sensors collect information from the agricultural field and send the data to a centralized system for processing and monitoring, and this helps the farmers make better decisions and improve the crop productivity. Now the first layer here is the sensor layer, which is used for field monitoring. So and it is one of the important layer in the smart agricultural system, and it consists of different sensors which are placed in the agricultural field to continuously collect the information about the environment and the crop conditions. And these sensors act like the eyes and the ears of the farming system and help the farmers understand what is happening in the field without constantly checking it manually. Now here you can see there are different types of sensors which are used for different purposes. You have temperature sensor, which measures the temperature of the field and help the farmers know whether the weather conditions are suitable for crop growth. Then you have the soil moisture sensor, which measures the amount of water present in the soil, and they help determine when irrigation is needed. Then comes the soil nutrient sensor, which detects the important nutrients such as nitrogen, phosphorus, and potassium in the soil, and it helps the farmers apply the right amount of fertilizer. Next, you have humidity sensors. These measure the moisture content in the air, which affects the plant's growth and disease development. Then last is the light sensors, where these measures the intensity of the sunlight reaching the crops and help monitoring growing conditions. So these all sensors, these will be continuously collecting the data and send it to the next layer of the system for processing and analyzing. And since the data it is collected automatically and in real time, farmers can make better decisions and improve the crop productivity. Okay. Then here you have one real-time example where a farmer here we'll consider a farm where a soil moisture sensor is installed. Okay, here soil moisture sensor is installed, and the sensor continuously checks the water level in the soil, and if the soil becomes too dry, then the sensor immediately sends this information to the smart farming system, and the system then it activates or automatically switches on the irrigation pump and supplies water to the crops. Now, once the soil reaches the required moisture level, the system turns the pump off. So, this automation helps the farmer to save the water, reduce the labor, and ensure that crops receive the right amount of water at the right time. So, as a result, crop health improves, resources are used efficiently, and overall agricultural productivity will increase. Thus, the sensor layer forms the foundation of the smart agriculture by providing accurate and real-time field information. So this is about the sensor layer. Second is the communication layer, that is the data transmission, which is used for the data transmission. Now here its main function is to transfer the data collected by the sensors to a centralized system or the cloud or the server for monitoring and the analysis purpose. Now, after the sensors measure the field conditions such as the soil moisture, then you have temperature, humidity and the nutrient levels, the information must be sent to the place where it can be processed and used for the decision making. So, since the sensors are often spread across the large agricultural fields, a reliable communication network is required, and this communication layer acts like a bridge between the sensors and the data processing system. So some of the common communication technologies which are used in smart farming are the Wi-Fi, which is suitable for the farms with internet connectivity and the short distance communication. Then you have LoRa, that is the long range, which is designed for long distance communication with low power consumption, and it is ideal for large farms. Then you have Zigbee. It is a low power wireless technology which is used for connecting multiple sensors over the shorter distances. And last is the cellular networks, which may be 4G or 5G, which allows the data transmission over the long distances using the mobile network infrastructure. And these communication technologies ensure that the sensor data reaches a gateway or the network device, and a gateway collects the data. Okay, this gateway, it collects the data from many sensors and forward it to the cloud or the server platforms or monitoring applications. Now here we'll see one real-time example where a large agricultural farm is there, where hundreds of sensors are installed at different locations, and these sensors continuously collect the information about the soil, moisture, then temperature, humidity and crop conditions. And instead of each sensor directly connecting to the internet, they use the LoRa network in order to send their data wirelessly over the long distances. Okay, so this LoRa, that is a long range network, it gathers the information from all the sensors and sends it to the nearby gateway device. Then the gateway it then forwards it to the collected data to the cloud server, where the farmers can view it through a mobile app or computer dashboard. And as a result, the farmers can monitor the entire field from one place without physically visiting every section of the farm. And this saves the time, and it reduces the labor cost and also enables quick action when any problem is detected. So communication layer, it plays a very vital and important role in smart agriculture by ensuring reliable and efficient transmission of data from the sensors to the monitoring and control systems. Then comes the cloud or the server layer, which is used for the data processing. So here, after the sensor data is collected and transmitted through the communication layer, okay, it reaches the centralized server or the fog device or the cloud platform. And this layer, it is often called as the brain of the smart farming system. Okay, because it processes and analyzes all the collected information. And the cloud server layer, it performs several important functions such as the data storage, where all the information received from the sensors, it is stored and it is stored in the databases or the cloud storage, and this allows the farmers to access the current and the past data whenever needed. Then comes the data analysis. Here the system analyzes the collected data in order to identify the patterns and the trends. For example, it can compare today's soil moisture level with the previous days in order to understand the changes in the field condition. Then comes the AI-based predictions. Modern smart farming systems use artificial intelligence and machine learning algorithms in order to predict the future events. And these predictions help the farmers make better decisions and prevent problems before they occur. Then you have the decision making. Last is the decision making. It is based on the analysis and predictions, and the system generates recommendations or automatically controls farm equipment such as irrigation pumps and the fertilizer dispensers. Now here you have a real-time example, which is where we will imagine a farm where sensors continuously measure the humidity, then temperature and the soil moisture, and this information is sent to the cloud platform through the communication network. Now, the cloud system stores the data and analyzes it using the AI algorithms, and it may discover that high humidity and warm temperatures create a favorable conditions for a particular crop disease. Now, the system then sends an alert to the farmer, allowing that, allowing preventive actions before the disease spreads. Similarly, the cloud platform can analyze the soil moisture levels and weather forecast, and if rain is expected the next day, the system may recommend delaying in irrigation to save the water. So, if the soil becomes too dry, then it can automatically schedule the irrigation at the most suitable time. So by storing, analyzing and processing large amount of data, the cloud or the server layer helps farmers make informed decisions, improve the crop yield, then reduce the resource wastage. And it increases the overall farming efficiency, and therefore this layer plays a crucial and important role in transforming the traditional farming into smart and data-driven agriculture. Then next is the application layer. Here this is the final layer of the smart irrigation system, and it is the layer through which the farmers, agricultural experts and the farm managers interact with the system. So after the data has been collected by the sensors, it is transmitted to the communication networks, and then it is analyzed by the cloud or the server, and the results are presented to the user in an easy to understand format. And the application layer can be accessed using the different devices such as mobile phones, laptops, desktop computers, tablets, and many other devices. Then these devices display the information here through the mobile applications, websites or the dashboards, and then the farmers monitor their fields anytime from anywhere without physically visiting the entire farm. So the application layer provides several useful services such as the crop health monitoring, where the system continuously monitors the crop conditions and helps the farmers identify unhealthy plants at an early age. Then you have water management alerts. Here it informs the farmers when irrigation is needed and helps prevent both outwatering and the underwatering. Then next is the pest detection warnings. Here, using the sensor data and AI analysis, the system can detect conditions that may lead to pest attacks and send warning messages. Next, you have the farming vehicle tracking. Here, the farmers can track the location and movement of the tractors, harvesters, and other agricultural vehicles. So, and one more is the automatic pesticide spraying. Here the system can automatically activate pesticide spraying equipment when harmful pests are detected, and reducing the manual effort. So one real-time example here is the where we will consider a farm where the soil moisture sensor continuously monitor the water content in the soil, and the collected data is analyzed by the cloud platform. So if the moisture level falls below the required limit, then the system immediately sends a notification to the farmer's mobile phone here. Okay, and the message may say like soil moisture is low in the field area 3, irrigation recommended. And this quick response prevents the crop damage caused by water shortage, and it improves the crop growth and also helps the farmer make timely decisions, save resources, increase the productivity and manage their farms more efficiently through easy access to real-time information. Okay, then here you have some real-time agricultural IoT applications. First is the precision farming. Here the sensors help apply fertilizers only where needed, and it reduces the cost. Then you have smart irrigation, where the water is automatically supplied when soil moisture becomes low. Next you have livestock monitoring. Here the IoT devices track the animal health and the location. Then you have vehicle tracking, where the GPS based systems track the tractors and farming equipment. And the last is the pest detection, where the AI system analyze crop images and detect the pest infections early. Now here in summary to this introduction for agricultural IoT system, you can say that sensors collect the environmental data from the farm, Then in the second step, the data is transmitted through the communication networks. And in the third step, cloud or server systems process and analyze the data. And in the final and the last step, farmers access the information using the smartphones or the computers. So here this system enables the precision farming. Then it improves the crop productivity, reduces the water and fertilizer waste, and early pest detection and crop health management. Okay, so and also it increases the farm revenue. That is the most important thing here. So this is about the introduction to agricultural IoT systems. Thank you.